Astronomers just realized something unsettling. They completely missed one of the most powerful explosions in the universe. Not because it was small, not because it was far away, but because it never showed itself directly. There was no bright flash, no warning, no dramatic signal pointing right at Earth. Instead, it left behind something else. A faint, persistent signal that kept talking across space for years, and by the time astronomers noticed it, the actual explosion was already over. So what kind of cosmic event is powerful enough to shake the universe and still go completely unnoticed? How did astronomers piece the event back together after the fact? And more importantly, could another one be happening right now without us noticing? Let's find out. Here's where the story takes a strange turn. Astronomers didn't discover the explosion itself. They found the aftermath, a mysterious radio source cataloged as ASKAP J005512-255834 appeared in the data like a delayed clue, not flashing, not repeating in a familiar pattern, just there, quietly evolving over time. And that's what made it dangerous to ignore, because this wasn't behaving like anything typical. It wasn't a fast burst that disappeared. It wasn't a steady signal that stayed constant. It changed dramatically. Over the course of less than a year, this object brightened nearly 20 times. Then it refused to disappear. It lingered for more than 1,000 days. That alone was enough to raise alarms. Because in the universe, events this powerful usually don't stay quiet. They explode into view and then fade quickly. But this one didn't follow the rules. It was as if astronomers had arrived at the scene of a massive cosmic disaster, and the only thing left was debris, still glowing in the dark. So what were they actually looking at? To understand that, you have to understand how it was found. The signal was detected using ASKAP, a radio telescope built for one purpose: to scan massive areas of the sky all at once. Unlike traditional telescopes that stare at a tiny region and hope to get lucky, ASKAP sweeps across enormous sections of space continuously, which means it can catch things others completely miss. And in this case, that ability may have revealed something we were never supposed to see this way. Because what ASKAP found wasn't the explosion, it was the echo. Not an echo you can hear, but a lingering radio afterglow. A signal created when something incredibly violent slams into surrounding matter and keeps radiating energy long after the original event is gone. In simple terms, the main explosion happened. We missed it. But the shockwave it left behind kept talking. And that leads to a disturbing possibility. If this event was only discovered because its echo lasted long enough, then how many others have already happened and faded away before we ever noticed? At this point, astronomers had a mystery. They didn't see the explosion, they only had the aftermath. So they did what scientists do best. They reconstructed the crime scene, and one explanation quickly rose to the top. This might be something called an orphan afterglow. The name sounds strange, but the idea is powerful. Some of the most violent events in the universe, gamma-ray bursts, release narrow, focused jets of energy. If one of those jets is pointed directly at Earth, we see it instantly, a bright, unmistakable flash. But if that jet is pointed somewhere else, we see nothing. The explosion still happens, the energy is still released, but we miss the entire opening act, until later. Because over time, that explosion expands, it slows down, it crashes into surrounding gas and dust, and begins to glow in radio wavelengths, from all directions, which means eventually, even observers who missed the initial blast can start to see the aftermath. That's the orphan, an afterglow, with no visible parent explosion. And the evidence here is hard to ignore. The way the signal brightened, the way it faded slowly over years, the energy involved, the environment it came from, all of it points in the same direction. Even the host galaxy tells the same story. This object is located in a star-forming galaxy, the exact kind of place where massive stars live fast and die violently. About 1.7 billion light years away, something catastrophic likely happened. And we didn't see it, we only found the aftermath. And that changes something fundamental. Because for decades, our understanding of these explosions has been biased. We've mostly studied the ones that pointed directly at us, the ones that were impossible to miss. But this discovery suggests something bigger. There may be an entire hidden population of massive cosmic explosions happening off-axis, unseen, uncounted. And if that's true, then the universe is far more active than we ever realized. But just when this explanation starts to feel solid, the story takes another turn. Because astronomers aren't fully convinced, there's another explanation, and it's just as extreme. What if this wasn't a gamma ray burst at all? What if this was a star being destroyed by a black hole? A tidal disruption event. A moment when a star drifts too close and gravity tears it apart. The most famous examples happen at the centers of galaxies, where supermassive black holes live. But this case is different, because if this explanation is correct, then the black hole responsible isn't in the center. It's somewhere else, hidden, an intermediate mass black hole, a category we barely understand, hard to detect, hard to confirm, and rarely seen in action. If that's what this is, then astronomers may have just uncovered evidence of a black hole operating where it shouldn't be. Again, not through a dramatic flash, but through a slow, lingering signal. And that's what makes this discovery so powerful. Because no matter which explanation is correct, both are rare, both are extreme, and both reveal the same uncomfortable truth. The universe doesn't always show us its biggest moments live. Sometimes, it hides them, and only leaves behind traces, signals that arrive late, signals that evolve slowly, signals that force us to piece the story together after it's already over. And that means something bigger's happening here. This isn't just about one object. It's about how we discover the universe itself. For decades, we've relied on bright, immediate events, flashes, bursts, explosions we can see in real time. But now, radio astronomy is changing the game. Instead of catching the moment, we're learning to read the aftermath, to find the echoes, to uncover events that never announced themselves to us. And that shift may reveal a universe that is far more violent and far more active than we ever imagined. What makes this discovery unforgettable is not just the scale of the explosion, it's how we found it, not at the moment, but long after it was gone. A massive event may have already shaken its corner of the universe, while Earth saw nothing, no flash, no warning, just silence. Until years later, when a faint signal refused to fade away, and finally told its story, which means right now, somewhere out there, another event like this could already be unfolding, or worse, it may have already happened, and all that's left is the echo, still traveling across space, still waiting for us to notice. So here's the real question. If one event this massive could go unnoticed at first, what else do you think might still be out there waiting to be found? Drop your thoughts in the comments. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries.